This is our second video for maximizing and minimizing. So here's our first problem. We're going to do two in this video. A dairy farmer plans to enclose a rectangular pasture adjacent to a river. To provide enough grass for the herd, the pasture must contain 5,000 square yards. No fencing is required along the river. What dimensions will use the least amount of fencing? Right there is what we're looking for. Since these are maximizing and minimizing, when you see least amount, what they're asking you to do is minimize. And then the fencing, which is basically our perimeter when you make something. So let's draw a picture and draw our fencing. So it says we have a river, and we're going to make a rectangular pasture adjacent to this river. No fencing is required along the river, which means we should label each side with a variable. So if you look at this, our fencing is made up of two x's and a y. This x is the length for that side, and that x is the length for that side, and that length is for the y. So you just picture him putting down fencing here, here, and here. He would have to have that length, and that length, which is this. Now, when we do these functions, we need them to be in terms of one variable. Otherwise, we have to use implicit differentiation, and I don't think we want to do that. So we need another equation for y, and that's what that other information is given. So it says to provide enough grass for the herd, the pasture must contain 5,000 square yards. That's an area. So area of a rectangle is xy. Now we can solve for y like we've been doing before to write our function in terms of one variable and substitute it. And there we have it. So let's rewrite it. This is our fencing function that we're taking the derivative of. So if we take the derivative, set it equal to 0, it'll give us what we need. So we have f prime of x equals 2 minus 5,000 over x squared. And now we can rewrite it, or we can just set it equal to 0 and solve. And I'm going to use that second one. So 2 equals 5,000 over x squared. A little cross multiplying. So we get 5,000 over 2. Which is 2,500. So if we square root both sides, we get x is equal to 50. So 50, not feet, yards is what we need. And the nice thing is that the secondary is you just come over here and plug it in. And so y equals 100 yards. So what dimensions will use the least? We need a 50 by 100 yards, with 50 being the x and 100 being the y. So again, when you do these problems, you're looking for what are we trying to minimize or maximize. That's the function we need to create, and we need to make sure it is in terms of one variable. So if there's any other info, that is to make a secondary equation. Let's try another one. So find a positive number such that the sum of the number and its reciprocal is as small as possible. So what we need to do is make that little function. So let's just call it function for x. And it says that this needs to be as small as possible, which means we are minimizing. And that function is starting here. It says such that the sum of the number and its reciprocal. So it says the sum of the number and its reciprocal. So if we translate this, sum goes here. That's plus number. And then reciprocal just means to flip it, like that. So that is our function, x plus 1 over x. It's all one letter. So now if we take the derivative, we get 1 minus 1 over x squared. It's just like we did up here. And then set it equal to 0. X squared equals 1. Square root, x equals plus or minus 1. But it does say positive. So 1. So find a positive number such that the sum of the number and its reciprocal is as small as possible. Now if you think about this, think about it this way. If I were to plug in 1 to verify this, that's 1, and that's 1, that's 2. But any other number that I plug in, you're going to be flipping it. So if I did 1, it'd be 1 plus 1 over 1, which is 2. Now if I pick 2, it'd be 2 plus 1 over 2, which is equal to 2.5. And if I did 3, it would be 3.5. And you're thinking, oh, well, let's just get creative. Sorry, 3 1/3. let's get creative then and start with a fraction. So how about 1/7? Well, reciprocal would be 7, so it's 7/7. The whole idea is that if you pick a fraction, the reciprocal is going to be a large whole number. If you pick a whole number, well, it's already bigger than 2, because the next number is 2. So yes, 1 would be our answer. It checks perfectly.